Oh, hey. Oh, I'm really excited because I actually have season tickets to my favorite baseball team. And that actually reminds me of a really interesting riddle that actually involves us thinking about really, really big numbers, but seeing that we can actually multiply using mental math, just thinking it through. Let's take a look together and use our minds to do mental math. Okay, when the full season tickets first went on sale, 2,000 full season tickets were sold for Section L. So let's take a look at this table. Here's Section L, full season tickets. Those are $30. Okay, then 2 weeks after tickets first went on sale, another 1,500 full season tickets were sold for Section L again at $30 a pop. Now, here are the two questions for us to think about. First of all, how much money was spent on full season tickets for Section L in total? And then, how much more money was spent when the tickets first went on sale than after the first 2 weeks? Lots of information here. Let's parse it a little bit at a time. So the first thing we have to do is we have to find out how much money was spent in total on Section L full season tickets. So we know that the first one on sale, we had 2,000 sales at $30 each. And so what we have to figure out here is, well, 30 times 2,000. And then what happened later? Well, a few weeks later, we see that then another 1,500 full season tickets were sold. So that's going to be, again, at the price of $30, and now times 1,500. And then if we want to know how much money was spent in total for season tickets in Section L, we want to take this answer and add them up. All right, well, let's have some fun doing some mental math. So mental math. Well, there's lots of ways of thinking about this, by the way. There's not just one way. Now, here's the first thing I notice. 3 times 2 is, in fact, 6. So that's going to give me a clue. But I got to figure out now what comes after the 6, right? How many zeros are there going to be? Well, here's a way of thinking about it. This is 2 thousands, and this is 3 tens. Now, what's 1,000 times 10? Well, actually, 1,000 times 10 is 10,000. So I have 10,000, and then I have 3 times 2, that's 6. So I have 6 times 10,000, or 60,000. So this is 60,000. 60,000. Okay, great. So that was a neat way of doing mental math. Now, what about this one here? Well, what about this? Well, again, I know that I have 3 tens, and then here I have 1,500. So let's just take a look at the 3 times the 15. Now, if you think about it, 3 times 15, this is a little bit tricky mental math, but if we think about it, we see it's 45. So we have 45, but we have 45 thousands. So we see we have 45,000. And so now, if we want to know the total for season tickets for Section L, we just add these numbers. Well, this is easy to do because we know what 6 plus 4 is. That's just, in fact, 10. So we can quickly see that we get this large number of 150,000. And what are the units? Wait, not $150,000, $105,000. Don't let me make mistakes like that. Okay, so we see now that the total sum was $105,000. Now let's answer the second part of the question, which is how much more money was spent when the tickets first went on sale than after the first 2 weeks. Now, how much more? That means we're looking for a difference between two numbers, which means when I hear difference, that means subtraction. And so what we want to do now is use what we've done and a little bit of creativity to realize that how much more means subtraction. So I want to take a look at the money spent in the first 2 weeks and then subtract off the money spent after the first 2 weeks, and that will give me how much more, and that's what I want to figure out. Well, this we already did, because that we see is $60,000, and this we already figured out, that is actually $45,000, and so we're looking for the difference. So what I want to do here is actually subtract, and I'll write it out, but I want us to use mental math, but just so that we see what's going on here. So we see 60,000, these are dollars, by the way, minus $45,000. But let's just do mental math. Okay, so this is 60 thousands, and this is 45 thousands. But what's 60 minus 45? Well, if we think about that a little bit, we can see it's actually 15. So we have 15 thousands. 15 thousands. So that's the answer. So we see that this actually equals $15,000. And what does that represent? That represents, in fact, I'm going to bring it right up here so we can see it for ourselves. $15,000 more was spent when the tickets first went on sale than after the first 2 weeks. And we see that by doing some mental math and also realizing that when we hear how much more, that's our cue for subtraction. Well, lots of interesting questions we can see all around us in mathematics, even when we're thinking about looking for season tickets. The really cool thing is that we can use mental math sometimes to see exactly what those numbers should be. And of course, the great thing is that we actually have seats because you want to have a perfect fit. And when that entire stadium gets all filled up, you might not have room. But luckily, we have room because we have our season tickets and just as much room as I have in my glove. It's just as much room. Oh gosh, I hope I have tickets. Have fun with math. We'll see you soon.
Let's do a little bit of practice here. So let's start with the problem of the day today. It says Mr. Beck usually drives 182 miles each week. But last week, he drove 3 times as many miles as he usually drives in a week. We want to estimate the number of miles that he drove. Let's start by looking at some important information. We know he usually drives 182 miles per week, but last week he drove 3 times as many miles as that. So we want to estimate. Remember, when you're estimating, you're finding about how many and not the exact amount, all right? So if we look at the number 182, miles per week. Last week, he drove 3 times that many. So we're going to multiply 182 times 3. Remember, we are estimating. So let's take 182 and let's round it to the nearest 100. So 182 round to the nearest 100. This 8 here tells me I'm going to round up to my hundreds. So if I have 1 in the 100s, I round up to the next 100. It is rounding to 200. Now I'm multiplying 200 times 3. Let's go ahead and solve. 2 times 3 is 6. And I have 2 zeros. So this tells me he drove about 600 miles last week. Let's look at another example. So how can you use mental math and properties of multiplication to help you multiply numbers? Well, let's think about some ways that we have already learned to multiply numbers or ways that you've learned to multiply in the past. So, have you ever done math in your head? Like without a calculator, without a pencil and paper, without manipulatives, just all in your head? That's one way we can do math using mental math. Okay, and you can multiply using mental math. Only your brain, no pencil to paper, no calculator, no manipulatives. All right. So, and there's a couple ways you can do this. Once we get more familiar with numbers. So let's go ahead and do a little bit of practice.
Hi there. It's a nice evening at the diner. Denzel the dragonfly and I are checking out the new fire hydrant. For safety reasons, the firefighters have installed this fire hydrant. They are installing 3 fire hydrants near this road. Click the fire hydrant to see how much it costs. Okay, a fire hydrant costs $152. So the firefighters plan on installing 3 hydrants on this road. How much do you think that will cost? You know, we can use mental math to figure that out. Let's try it.
Let's see how you can use mental math and properties to help you multiply numbers.
Okay, before we do that, let's go back and let's work
To
on
find
our
out the
problem.
number of seats, you need to multiply the number of sections times the number of groups in each section times the number of seats in each group. So the number of seats in the theater equals 4 times 8 times 25. Using properties can make the problem easier to solve. The commutative property lets you change the order of the factors in a multiplication problem. Think about which two factors would be easiest to multiply.
What do you think, guys? Which two factors would be easiest for you to multiply? The 4 and the 8? Or the 8 and the 25? See.
This order shows 4 times 25 first. That will help since we can find 4 times 25 mentally.
So 4 groups of 25. Think about 25 plus 25 plus 25 plus 25.
You can skip count by 25 4 times. So 4 times 25 is 100. Now multiply 100 and 8. 100 times 8 is 800. So there are 800 seats in the theater.
In this equation, we looked at the number 25, and I knew that 25 plus 25 plus 25 plus 25 equals 100. I'm thinking of it in money terms. So you did it that way, or you could have multiplied 4 times 8 and find that product and multiply by 25. That would have worked too.
You can use a combination of multiplication properties to make problems easier to solve. Let's try using the commutative and associative properties to solve this problem. 4 times 7 times 250. First, let's reorder the factors using the commutative property.
So your factors are 4, 7, and 250. We're just going to put them in a different order.
This order shows 250 times 4 times 7. The 250 is next to 4. Since we can find 250 times 4 using mental math, change the grouping to multiply them first. Which property can you use to do it? You can use the associative property to regroup the factors in different ways and get the same product. Now let's use mental math to find 250 times 4. We can skip count by 25 4 times and use a pattern of zeros to find the product. So 250 times 4 is 1,000. Now multiply 1,000 and 7. So the product is 7,000. Let's try some other mental math strategies that can make multiplication easier. You can use friendly numbers. They are numbers that are easy to multiply mentally. Let's multiply 32 and
Right, and then we're going to pause there on that part, and we're going to do some together because we don't use friendly numbers a lot when we are multiplying and doing our math. We use a lot of estimating and rounding, so I don't want to confuse you guys. So let's go ahead and do some practice. Grab a paper and pencil, and we'll continue. So when we're multiplying, we've looked at a couple different strategies, and I encourage you to use whichever strategy that works for you, okay? Whether we're doing mental math or not. So I'm going to go through a couple examples. And I want you to why it does that. 625. All right. 4 times 625. I'm going to take this number of 625 and break it apart into my hundreds, plus my tens, plus my ones. Okay, I'm multiplying all of those times 4. So we have 4 times 600 plus 4 times 20 plus 4 times 5. And basically, I'm doing the area model. I'm just not drawing the picture with it this time. 4 times 600 is 2,400. 4 times 20 is 80. And 4 times 5 is 20. So now I'm ready to add 2,400 plus 80 plus 20. Let's see, my ones, 0. 8 plus 2 in my tens is 100, so I'm going to need to regroup. And that 4 in the 2,400 becomes a 5, and that's a 2. So it's 2,500. That's one way to multiply. Okay. Let's try another one. Right, I'm going to do another example of multiplication. 5. Does that 5 times 398. And this time I'm going to rewrite my problem vertically, so it makes more sense to me to multiply. 398 times 5. Let me erase this one. Don't need that one. All right. So I'm going to multiply by my ones. 5 times 8 in my ones is 40. I'm using partial products. I'm just writing the multiplication out. I'm not regrouping or anything. I go to my tens. 5 times 9. But it's just 9. It's 9 tens. So it's actually 90. So I'm going to add my 0. 5 times 9 is 45. So 90 times 5 is 450. Okay, so this one was 90 times 5. Sorry about that, guys. And this first one was 8 times 5. My next one, I'm going to do 5 times 3, but it's a 3 in the 100s. So it's actually 300 times 5. My 2 zeros for my place value. And 3 times 5 is 15. So this one was 300 times 5. All right. So now I'm going to add 40 plus 450 plus 1,500. And I got 1,990. Okay. So let's do one together. I'm going to go a little bit slower so you can go step by step with me as you are multiplying. And let's do this one, breaking it apart, and let's use the area box model. So we're drawing that picture. Okay, so I'm going to draw my box. Make sure I have 4 boxes, one for each place value. Doesn't matter if they're not perfect. My 6 is going to go along the side because I'm multiplying the 6 times every other number in the box. And we're going to break 1,438 apart into expanded form for each place value. So start with our largest place value, which is the thousands. I have a 1 in the 1,000, so it's worth 1,000. I have a 4 in the 100s, so it's worth 400. 3 in the tens is 30. And 8 in the ones is this 8. Right? So this means each box I'm going to be multiplying by 6. I'm going to do 6 times 1,000. Write the answer in the first box. 6 times 400. Write the answer in the box under the 400. 6 times 30. I'm going to write the answer in this box here. 6 times 8. And write the answer in this box. So go ahead and multiply. And we'll come back and we'll check our work. Okay, let's look at our work. 6 times 1,000. 6 times 1 is 6. I have my zero, so 6 times 1,000 is 6,000. 6 times 400, 6 times 4 is 24. I drew 2 zeros, so it's 2,400. 6 times 30, 6 times 3 is 18. And add your 0 for your hundreds. 6 times 8, 48. All right. Now, you have your 4 products here. You have 6,000. You have 2,400, 180, and 48. I'm going to take those 4 numbers and I'm going to add them up. So go ahead and write them down and add them up. Guys, ready to check your work? So you should have written out your problem. Make sure you line your place values up. 6,000, 2,400, 180, and 48. 8 in your ones. 8 plus 4 is 12. Regroup 1. 6. 6 plus 2 is 8. So it should be 8,628 altogether. So 6 times 1,438 equals 8,628. All we did was take the numbers we got here was 6,000, 2,400, 180, and 48, and I rewrote them into an addition equation, and I was able to add. Let's do one more together. What if I have, let's do one like they did in that equation with the 3 multiplication numbers. We won't see these a whole lot, but we will see them sometimes in our work. We have 8, 25 times 23. Now, let's look at this because I want to find the product of these numbers. And I'm going to think about numbers that might be easier for me to multiply than others. And I definitely want to do my 8, okay, because it's a single digit number. And then I'm going to multiply that by 25. So I'm going to multiply 8 times 25 first and find the product of that. What I know about 25 is I know it takes 4 25s to get to 100. I have the number 8 here. If I split up 8 into 4 plus 4, let's get rid of that line for us. 4 plus 4, and then multiply that by 25. Okay, then I will have 4 times 25 plus 4 times 25. Okay, 4 times 25. Oh, I still need to multiply the whole thing by 23 when I get there. So I'm going to put that there so I don't forget. 4 times 25 equals 100. 4 times 25 equals 100. So now I have 100 plus 100 times 23. 100 plus 100 equals 200. And I'm going to multiply that times 23. I'm going to go to my next page so I can show you the work. Okay. 200 times 23. Now, when we get to this part of it, let's start by breaking up the number 23 again, because I really don't want to multiply by a 2-digit number. So 23 20 plus 3. Okay, which is actually, believe it or not, is going to be a little bit easier. So if I have 200 times 20 plus 200 times 3. 2 times 2 is 4. I have 1, 2, 3 zeros. So 200 times 20 would be 4,000. Now 200 times 3. 2 times 3 is 6. Under 2 zeros, 600. So now I have 4,000 plus 600. Be 4,600. You're going to do a few problems like this as practice today, and probably practice a little bit tomorrow. So just please ask the teachers if you need some help, and if you get stuck on it, there will be some fluency problems to do at the beginning of your lesson, independent work, before you do a couple multiplication problems. All right, you guys are doing awesome and you're rocking it. Please ask for help if you get stuck. Okay.